And so, as I have been saying all along, ultimately we want to be able to solve our ratio problems using ratios as equivalent fractions. So that's what I'm going to do real quick with this one, as opposed to showing you the ratio table again. Still, the ratio tables aren't a bad option to use on as we're learning, but we do eventually want to get into using equivalent fractions or equivalent ratios as fractions. So, for instance, your neighbor pays you $17 for 2 hours of work, and then on Saturday you work 8 hours. How much are you going to get paid? So, as any equivalent fraction, you solve equivalent ratios the same way. You can multiply or divide the top and bottom number by the same value. So here the question is, well, how many hours or how many times would you multiply 2 to get 8? And you'd multiply 2 times 4 to get 8. And since you multiply the bottom times 4, you multiply the top times 4. And 17 times 4, using the distributive property, 10 times 4 is 40. 7 times 4 is 28. 28 plus 40 is $68. So you would get paid $68 for those 8 hours of work. So that's how we would use an equivalent ratio to solve a word problem as fractions. So the next thing we're going to do is we're going to look at rates. And rates are ratios. They're just ratios that compare two quantities of different units of measure. For instance, if we look at the picture, $27 to 3 pizzas. That is a rate. One unit measure is money, the other unit measure is pizzas. A unit rate is a rate, same thing, but this compares the quantity to a single unit of the other measurement. So in the example below, we first are talking about $27 for 3 pizzas. The unit rate would be $9 per pizza because we're talking about the cost for one pizza. So unit rates compare a quantity of one unit of measure to a single quantity of the unit of measure. Equivalent rates, they are just that. They're rates that have the same unit rate. They are rates that express the same relationship between the two quantities. The big thing when working with rates is that we want to make sure our labels work, our labels match up with one another when we write out the ratio problems. Just like the one back here about your neighbor and doing yard work with your neighbor. On the top, I put the currency, the money, and on the bottom, I put the length of time. I could have solved the problem the exact same way, putting the time on top and the money on the bottom, as long as you're consistent. And they got to be the same unit of measure. Don't get tripped up if they ask you, well, how much do you get paid for working 90 minutes? Well, then you got to change your rate to reflect to minutes as opposed to hours. All right, so that's the big thing when working with rates, is to make sure that you label each part of the ratio, and as you're working with them, they're lined up with one another. Whatever unit measure on top of one ratio, the same unit of measure is on top of the other ratio. Right. One way of illustrating unit rates is using a double number line, and it's just that. It's a number line that has two different scales on it. They mark off the same location, but the numbers represent different quantities. So if we look at the example that they give us, talking about 600 points for four notes in a video game, like a Band Hero or one of those video games. And so that is what we're going to talk about now briefly, is look at another type of double number line that you might be familiar with. So my question for you is, what's another double number line that you might be familiar with? And the answer, a map scale. A map scale is just that. It is a double number line. Sometimes it's drawn as a box similar to this, but on one side of the double number line, you have one unit of measure. And on the other side of the number line, you have a different unit of measure, but they're marked off in the same spots. They just mean different quantities. So this is for reading a map. How many inches represent well, in this case, 50 miles, is represented by 1 inch. So that's one place that you should be familiar with using the double number line. A little bit more on unit rates. A unit rate is a rate that shows the relationship between one quantity of one unit measure and a single unit of the other measurement. Miles per gallon, dollars per pound. How much does it cost to buy 1 pound of something? Miles per hour. How far will you travel in 1 hour? Points per game. What's the average, your average score per game on points scored? So an example of a unit rate would be, for instance, let's say you travel 75 miles in 3 hours. And the question would be, well, how many miles is that per hour in 1 hour? Okay. And then we find that by, well, just like you can multiply the top and bottom number by the same value to get an equivalent ratio, we can divide the top and bottom by the same number to get an equivalent ratio, in this case, our unit rate. Because when we have 3 hours, we want to divide it by 3 to get to the 1 hour, and then 75 also divided by 3 would be 25 miles per hour. So you're not making great time, but that would be the unit rate. If something travels 75 miles in 3 hours, then it's traveling approximately 25 miles per hour, and that being the unit rate. So we have the rate here, and then the unit rate over here. Okay. So let's do this one problem to find an equivalent rate by way of the unit rate. And the question tells us to use a ratio table. I'm just going to use the equivalent ratios. A chef buys 6 pounds of salmon for $51. How much will the chef pay for 9 more pounds of salmon? Using equivalent ratios, we're going to find out the cost for 9 pounds of salmon fillets. So if we look, we have 51 for 6 pounds, and then how much for 1 pound? Well, to go from 6 to 1, using division, it would be divided by 6, and then we would divide the top by 6, and 51 divided by 6 is 8.5. If you look, I did the division, and it ends up with a decimal. Do not just take the remainder and 0.3. You gotta finish the division, add zeros on, keep dividing until either the fraction terminates, repeats, or you don't even get a decimal. All right, so we have $8.50 for 1 pound. Now the question asks, how much is it for 9 pounds? Well, 1 times 9 is 9. If I multiply the bottom times 9, I need to multiply the top times 9 to get my answer. So I multiplied my fractions my decimals as if they were whole numbers. And I get 76.5. So 8.5 times 9 is 76.5. So for those extra 9 pounds, it's going to cost you an additional $76.50 to buy the salmon. Okay, we'll try one or two together of these rate problems or unit rate problems. Write a unit rate for the situation. So you saved $28. $28 in 4 weeks. The unit rate, well, how many dollars is that per week? And divide top and bottom by 4. And we get $7 per week. Okay, that's the unit rate for savings. And then since it's right here below, let's look at number 9. Again, a unit rate. This is a rate, 270 miles in 6 hours. Well, the unit rate would be how many miles per hour. And to go from 6 to 1, we divide by 6. That means we're going to divide 270 by 6 also. And we get 45 miles per hour for that unit rate. So they're equivalent, they're traveling just as fast, but it's a comparison to a single unit of the other measurement. So I'm going to leave these other 4 for you to try and come back in a second and check them out. Okay, so here are the results. We did 7 and 9. Let's look at 11 real quick. 2,520 kilobytes in 18 seconds. Divide top and bottom by 18, and you find out that's 140 kilobytes per second. Number 8, 18 necklaces made in 3 hours is the same as 6 necklaces made in 1 hour. 228 students in 12 classes. Divide top and bottom by 12, and you find out that's 19 students per class. And then 880 calories burned in or contained in 8 servings would be 110 calories per serving. We'd be dividing top and bottom by 8. So that's a way to use unit rates, or to determine unit rates, is that you would divide them both by the measurement that you're looking to get to a single quantity. So if you're starting with 8 servings, I'm going to divide them both by 8 so I can get down to 1 serving. So that is using unit rates. And these here are some unit rate questions. I'm going to tie them into the Google document for you to try after watching the video. Thank you.